Hello, everybody. Welcome back. Sorry we didn't have class on Tuesday. I'm feeling a lot better. So we're going to start off this. I haven't changed the due dates yet on our homework assignments, but I promise you they will be fixed probably later today. So I'm going to probably extend the due date of this until next Sunday just to match up. So section 1.3 is on triangles and dimensional analysis. Dimensional analysis just makes it sound way more intense than it is. It's really just called unit conversions. But either way, we'll start off today. We'll talk about triangles, and I don't really know why dimensional analysis is in the same section as 1.3 from our textbook, but I guess because 1.3 we have to do with proportions. So and dimensional analysis deals with proportional relationships, but we'll get there. So we'll start off with triangles. So first thing is types of angles. There are three main types of angles, which are the right angle, once again, if you know this stuff, awesome. If you don't, no big deal. This is exactly 90 degrees. And so the way we denote it, when you have a right angle, we denote it with a little box. If you don't see a box, you should not assume that it is a right angle. So unless you see that little box, you should assume that it is not a right angle. Then you have the two other types, which are acute angles, which are angles that are less than 90 degrees. That looks something like this. And so on anything other than a 90-degree angle, you could just kind of draw an arc. Just draw kind of a little arc to symbolize that it is an angle that you're looking at. And then the last one are obtuse angles. So those are greater than. So 100 degrees, 150 degrees, 3,000 degrees, doesn't matter, as long as it's an angle larger than 90 degrees. And so those usually look like this. Once again, we're not going to draw a little box because this is not a right angle. And the reason why we know one of the types of angles because those define the different types of triangles. So then we have the triangle classifications. Triangle classifications. Now there are two different ways we can classify triangles. We can do it via their angles, or we can do it via their side lengths. So we'll start off with the angle classifications. Now, before we actually write them down, I want to write an important fact that we need to know about triangles. If you don't already know it, and just I say this because I want it to humble me. I'm sure I knew this at one point when I was learning triangle classifications and everything like that, but I ended up teaching math, what we call math 127 here, but it was called math 1149 at OSU, and I was teaching it, and it finally hit me why it's called a triangle. It's three angles, and I was in the middle of a lecture. I was like, oh, and that was pretty embarrassing, but I didn't realize that was the fact. But I've always been a little bit slow on those types of things. I didn't realize why it was called an evergreen tree. It's because it's always green. So so it is evergreen.
That one actually just.
Like so yeah, like I'm glad I'm not alone on that one. But yeah, so the triangle, did not realize. Other stupid thing that I did not realize. So when I was a kid, my parents always told this joke was the last thing that goes through a bee's mind when it hits a windshield. His butt, right? Because slams into the windshield and butt goes through its brain when it slams. So that's the joke. That's the funny joke. But I just thought it was funny because it said butt in it. So, and I retold the joke and I said, what was the last thing a bug thinks about before it hits the windshield? And I said it's butt, and I thought that was funny, but it's completely missing the point of the joke, which is the play on words. So I'm a little bit slow sometimes. But the reason why I bring that up is that the three angles of a triangle always add up to 180 degrees. No matter what triangle you have, it'll always add up to 180 degrees if you add up all the three angles inside it. The three interior angles should always add up to 180 degrees. So for the angle classifications, there are three of them. There is a right triangle, which is a triangle with a right angle. And so those typically look like this. And we'll talk more about right triangles later on because right triangles have a lot of very, very important facts about them. But for right now, we're just going to be talking about the classifications. But a right triangle is a triangle that has a 90-degree angle. And in fact, you can have at most one 90-degree angle. If you had two, 90 plus 90 would be 180. That would mean that your last side length would have to be 0 because you can't have it be more than 180 degrees. So you can only have at most one right angle, and so that's what we classify right triangles as. It's the ones that have a right angle. Then you have two, which is an acute triangle. Which are a triangle with all acute angles. So those typically look something like this. So notice that all those angle measurements are less than 90 degrees. All angles are acute. And the last one, 3, is the obtuse triangle. Which is a triangle with an obtuse angle. And just like with right triangles, you can't have more than one obtuse angle because if you did, you'd be adding up to more than 180 degrees. So they typically look something along these lines. I end up doing it from. Okay. The other three category classifications come from side length measurements. We'll do all the classifications and then I'll open up for questions if there are any. I know it's a lot of definition writing and I'm sorry about that. I like to spend more time on the math stuff, but right now we gotta get these all out of the way so we can be able to classify them. There's a couple questions on your homework to deal with that. So that's why I want to get these out of the way. The other type of one are the side length classifications. Did I mention this right now? No, I'll mention it later. No. Number one is the equilateral triangle. The equilateral triangle, as the name might suggest with the term equal, meaning that all the side lengths are the same. Equilateral triangle is a triangle with all side lengths of equal length. So for example, I'm gonna try and make sure I get this one right. I want it to be. No, that's not right. Okay, fine. I'll Bill, is this necessary? Probably not. Let's go like this. Yes, I am gonna do that. I am that person. Oh, this is gonna be dumb. Why am I the way that I am? Close enough. We're just gonna ignore that little spot right there. We're just gonna ignore that. Say what?
I don't think these plans.
Oh, good. Exactly. Yeah, we don't see it at all. Can't even see it right now. Perfect. So I'm gonna just amplify this just a little bit, which will make it more visible, but now we'll just fix that a little bit. There we go. And so all of these angle measurements are the same. So those little tick marks mean that all of those are the same degree, or like same measurements. So it's just like 4 centimeters, 10 feet, whatever it may be. But as a small little note that's really cool about equilaterals, cool would be not the right word. That's being a little bit generous. All angles are 60 degrees in an equilateral. And that's always true for equilateral triangles. They always have to be 60-degree angles, and that's kind of by necessity. Yes.
So, equilateral triangle is the same as equilateral triangle.
Ah, great question. Great point. Yes. So this, and I'm sorry, what's the name? Gabby. Gabby brings up a great point. These classifications are not they're not necessarily always the same. So like what I mean by that is you can have them be multiple classifications at the same time. An equilateral triangle is an acute triangle because all of its angles are acute. They're all less than 90 degrees. So all equilateral triangles are acute, but not all acute triangles are equilateral. Does that make sense? So you can have this one right here that I drew that was an acute triangle. This one's not equilateral, but it is acute. The next one are, for whatever reason, thank you, English language, this is isosceles, but it looks like isosceles. Isosceles. because English language is English language. You know, we're gonna remember, we're gonna try and change the way we say things. We're gonna say xylophone from now on, right? In this class, we say xylophone. Or if anybody's an Aliens fan, a xenomorph. But an isosceles triangle is a triangle with at least two sides of equal length. So you could draw it like this. You can have acute isosceles triangles. You can have obtuse ones. I'm going to draw an obtuse one, but it doesn't matter. Yep. And so here, these two sides, the two top ones, are equal, and the base is different. What? Looks like an ant. I can see what you're saying. As a small like terminology thing, the non side, this is called the base of the triangle. And the two equal sides are called the legs of the triangle. Let's use green. These are called the legs. And so you can isosceles triangles, you can have them be acute, you can have them be obtuse, you can even have them be right. And last one is just letting his or her their freak flag fly. They're going to be a scalene triangle. And a scalene triangle is one with all different side lengths, all side lengths different. Draw it like this. And so we see every side has a different side length. And similar to isosceles triangles, scalene triangles can be obtuse, they can be acute, they can be right. So the point being, as Gabby mentioned, is that all these classifications can overlap. A lot of them, like there's some that don't, but most of them can overlap in some ways. So we're gonna do an example of classifying these triangles based on their different, but based on both angle and. I'm going to enjoy the time when my son becomes a teenager and he gets to sleep in later than I do. Not liking the waking up at 4 thing. Not a big fan. Not a big fan of it. So example, we're going to classify the following triangles. So we're just, instead of writing a solution, we're just going to draw them as we go along. So the first one looks like this. And these are not drawn to scale, but it says 6 feet, 6 feet, and I draw it again. I can't handle that. So it's 6 feet, 6 feet, and then the base is 4 feet. Part B will be this, this, and then this one's 6 inches, 8 inches, and then 10 inches. And then C is this. And it's going to be 4 centimeters, 5 centimeters, and 10 centimeters. So, first one. You can usually fit every triangle into one angle classification and one length or side length classification. So the first one. Angle classification. Close to equilateral. If the bottom one was also 6 feet, then it would be equilateral, but instead it is going to be an isosceles. Yes, so it's isosceles because 2 side lengths are the same. But in addition to that, we see that all the angles are acute, so it's isosceles and acute. Oh, and I meant to draw this. I did exactly what I told you. I should have done that. We need to draw that little box to say that is a right angle, which means that that's a right triangle. That's a right triangle. And then in terms of side length classification, none of its side lengths are the same, so it must be scalene. And last one. That angle, if you're watching the recording, the angle in the bottom left is an angle that is larger than 90 degrees, which is an obtuse angle. So that must mean it is an obtuse triangle. And since all side lengths are different lengths, it must also be scalene. So those are all the side lengths, or all the classifying. So that's really what you want to do. Usually speaking, it's always 2 different ones. You can fit them into 2 different categories. So however you want to do it, if you want to do like look for its angle and then go to side length, or you want to do side length, then go angle, it's fine either way. But it's best to just kind of go down the list, make sure, see which ones it fits into, which category it fits into. All righty. So, any questions on classifications? Now let's do some actual math stuff. But in order to do the math stuff, we need to know the formulas for perimeter and area. So, perimeter and area. So if we've got a triangle, we're just going to draw a generic one. It doesn't matter what type of triangle it is, regardless of the triangle. Let's draw it like that. And then I want you to draw a line going straight down. So from this vertex here straight down becoming perpendicular with the base. And we're going to draw that in a dashed line to symbolize that it is not actually a side length. It is just a measurement, and it has to make a right angle here. And we'll call that measurement H. And then the one on the bottom here, we'll call that B. And so perimeter, once again, there are formulas for perimeters of things, but once again, I don't want you to memorize them. I don't want you to waste the time with that. Perimeter is the sum of all the side lengths. The sum of all three sides, not H. So remember, H is not a side length, so don't make that mistake. It happens once a semester, someone accidentally adds H and it breaks my heart. So H is not a side length. It is just a measurement that we use for area, because area is equal to 1/2 the base times the height. Or more aptly, more mathematically saying 1/2 B times H. So the base is always perpendicular to the height when you're calculating it. Now, just while people are writing it down, I'm going to show you the reason why. The reason why the area is 1/2 the base times the height. So I'm not sure if anybody showed you. Pretty cool. But if I took this and I duplicated it, I have two triangles, and what I could do is I could, come on, there we go. I could fit them together like that. And remember, this is H, right? And this is, so this is H, and I'm on, darn it. This is H, and this is B, right? That's a parallelogram. And what we learned from 1.2 was that the area of a parallelogram is base times height. And we learned that from like looking at the cool thing where you sliced off a triangle and put it onto the other side. So the area of two triangles would be base times height. So the area of one triangle would be half that. Hence, half the base times the height. Pretty cool. Fun little proof. But are you going to be expected to prove that? No, but now you can like just show it. I think it's pretty nifty. So I suppose I should write this though, just as a small note. The base is always perpendicular to the height. And just in case, like I realize I'm saying that word, but we haven't really described what it means. Perpendicular means that it forms a right angle. When you when they meet each other, they form a right angle. And then if you want to sound really, really cool, mathematicians, once we start going into higher dimensions, right? When you're talking about 2 dimensions, we use perpendicular. But once you start talking about 3 dimensions, you don't necessarily, you could have a right angle be at an angle itself. And you use a terminology called orthogonal. So orthogonal means, say, like when people say orthogonal in mathematics, they mean perpendicular. So now you can just sound like a real badass around your friends. Say, oh, that's orthogonal right there. And then they'll be like, oh, damn, I'm intimidated now. Something that I've noticed, like one of my biggest regrets about being a math teacher is that as soon as I tell people that I'm a mathematician, they get intimidated. Like they want to try and bust out into impressive terminology. I'm like, I'm just like you guys. I don't know anything about, like, I'm sure you know something that I know nothing about. It's been especially a problem with trying to make parent friends. It's been very, very problematic. So I tell them that I'm that, and they want to try and like show off that they're better than me in a lot of different ways. I'm like, listen, I can't do plenty of things that you can't do. Like I can't bake for crap. I can't sew. I can't do any of those things. My son is not like, I need to learn how to sew. I want to learn how to sew. I want to learn how to do cosplay. I think that'd be fun. But one day when I have time. Anyways, I'm getting sidetracked. My fault. So let's actually find area and perimeter. So find area and perimeter of part A will be this triangle. Once again, not drawn to scale. We don't need to worry about that. So it says 8 feet, 5 feet, and 11 feet. And then it has a dashed line here saying that that is 4 feet. And then part B, we'll be drawing a right triangle. And it says 12 centimeters, 13 centimeters, and 5 centimeters. I'll let you draw those and then we'll start doing the problem. Part A. Perimeter, always nice and neat. You just add up all the side lengths. So, and I'm going to abbreviate, instead of writing perimeter, because that's way too many letters to write, way too many chances for you to mess up the spelling. I'm just going to write P. And A for area, P for perimeter. And you can really write out, if you want to get yourself carpal tunnel, write out perimeter every time. But P, we're going to add up all the side lengths here. So that'll be 8 plus 5 plus 11, not the 4, because that's not actually a side length. That's just a measurement. So 8 plus 5 plus 11. So 8 plus 5 is 13 plus 11 should be 24. Wait, no. 24. 24. Got to remember our units, 24 feet. And once again, please feel free to use your calculator, especially if these numbers become like decimals. Some of the decimal ones can be a little bit intimidating. So please feel free to use your calculator. You're allowed to use
It was a 6 and not a 5.
Yeah, too. I thought it was.
Oh, that's the reason why. Yeah, it's supposed to be a 5. Sorry about that. You guys, that's clearly a 5, right? Thank you guys for calling me out on it. There we go. Thank you for catching that. So 5 feet. And then area, 1/2 the base times the height. 1/2 the base, which is 11, because the base is always the thing that is perpendicular to the height. And the height is 4. So that should be 44 divided by 2, which is 22. And it's feet squared. And so remember, so perimeter is a one-dimensional object. It's like measuring, like it's just how many feet you would walk across it or how many centimeters you would walk across it. Whereas area is a two-dimensional thing. In order to find area, you have to have 2 dimensions. Volume, you have to have 3 dimensions. So area, perimeter, feet to the first power. Area, did I say perimeter or did I say area for the first one? I can't remember. Perimeter, feet, area, feet squared, volume, which we haven't gotten into yet. Volume would be feet cubed. And then B. Perimeter, not too bad. Not too bad. 5 plus 12 plus 13. However you want to do it. However you want to add up the side lengths. If you wanted to do 13 plus 5 plus 12, it doesn't matter because of the commutativity of addition. And in case you don't, like commutativity means the ability to add them in any order you want. 2 plus 3 is the same thing as 3 plus 2. You can switch them around and everything works out. So 5 plus 12, 17 plus 13 is 30, right?
Yeah.
So 30 centimeters. And then area. It's 1/2 the base times the height. Oh, no, I don't have a base. Or though I have a base, but I don't have a height. I do have a height. It's 5. Because that is the side. Like, so with right triangles, it's a little trickier because the height is hidden as one of the side lengths. Because the side length, like the height is always perpendicular to the base. So because of that, that side length is actually the height. So I'm gonna write that down here. Let's make it. This side length is also the height because it's perpendicular to the base. So that's the only right triangles are the only ones where that happens because they're the only ones that have a right like a right angle, allowing you to have, yes.
So if there wasn't a right angle and it was like, there was no like, dash line in the middle, would it just be half of 12 as like the percentage of the base or?
Excellent question. So if it had been like this, if I had given you this triangle and I didn't like technically speak, and so I'm pretty sure looking back over the homeworks in my head, I'm pretty sure we try to make sure that there's always a right angle symbol. But if there isn't, you can't necessarily assume. And so if it didn't have a dashed line, we wouldn't be able to find the area at all because we wouldn't know what the height is. Yeah, we would say, oh, like there is an area, but we don't know it because it doesn't. Yes. Yes.
So that it, so if there's like no box in the corner, then we can just say like there's no area, we can't find the area.
We cannot find the area. So if it does, like, I'm pretty sure we always draw a right angle in the pictures if it is a right triangle for area. But if not, and you write that's not solvable and you get it wrong, please let me know on the homework and quizzes and stuff, and I will give full credit back on that situation. Because you're right, there should be a right angle on that situation. So
that's just like a trick question.
yeah, it should have a right angle on it, and if it doesn't, then that's a flawed problem. And let me know, and I'll work with Jim and Ronnie to make sure that gets changed in the future editions. Won't help you guys, unfortunately, but you'll be saving your future classmates. But I promise you, I will always give you full credit for that. So when it always like, I don't think I mentioned this before, and if I did, I'll mention it again. Please look over your work on your homework assignments and your quizzes. I try to make sure that you can look back over it and see what you got right and what you got wrong, so you can learn from your mistakes. And that way, for more like that's twofold. I forgot to mention this, so that's the important thing. Because our homework and our quizzes are online, you have this problem where you're trying to put your medium, which is your paper that you're working on, onto the computer. So you're looking down at your work, back up to the computer, to your keyboard, back to your work, back to the computer and stuff like that. There's so many chances for you to make a small error. Maybe instead of writing 12, you accidentally put a space, and so it's 1 space 2, and then it marks it wrong because it doesn't read it as 12. The computer doesn't see that. I would see that, but it does not. So be on the lookout for those. It's easy to make those mistakes. I made them all the time when I had online homeworks. And when that happens, just email me. Say, hey, Phil, on this homework assignment, 1.1, question 5, I put in 1 space 2, and I meant to write 12. I accidentally put in a space, or I accidentally put in the unit measurement when it doesn't want that. And I can easily go in and fix that for you. Worst thing that can happen, even if you're unsure, just email me. Worst thing that can happen is to say I can't give credit back, and I'll explain why. I'm never going to make you feel bad for advocating for yourself to get more points. That is always something that you should do. Like when we take our exams, look back over it. It's possible that I'm human. Sometimes I make mistakes. It's happened before where I accidentally graded something too hard. The one place where I would say, do not bring it to my attention is if I give you too many points. Don't let me know. Because even still, if I gave you extra points, that's my mistake. I'm not going to change it. But don't let me know if I accidentally gave you too many points. But if I did give you too little, let me know. It's happened before. I can count on like one hand since I started teaching, but like it's happened before where like a student got an 11, and I was using that bad scientific calculator, and I pressed 11, but it didn't register one of the ones. So I gave them a 1 instead of 11 on that problem. And so they lost out. Their grade dropped by a whole 10%. So easy fix, but just let me know. Please look over your work and everything. So anyways, back to the problem at hand, the area. So as we said, the base is 12 and the height actually ends up being one side length, the 5. So the area is 1/2 the base, 12 times the height, 5, which ends up being 30 centimeters squared. Which is interesting that they end up both being the same thing. The same number with different measurements. That can happen. You can end up having the same perimeter in the same area. Just worked out that way. Sometimes the area is bigger, sometimes the perimeter is bigger, sometimes they're equal. It all depends on the problem. And as a reminder, another one when it comes to the exam time, we're not there, we're not even close to that yet. But when it comes to that, if you do forget angle measurements or unit measurements, I'm only going to mark down once. And if I mark down multiple times, please let me know. The way I like to grade things is I like to grade them page at a time so that I'm so that I'm consistent with my grading throughout everybody. So that I make sure like if I decided to mark down for something on one problem, I'm consistent with all of you guys. I don't mark someone down unfairly. So if I do double penalize you, please let me know and I will make sure to give you the points back. Anyways, sorry, getting sidetracked there. Now, the next thing I want to do a small review of proportions. Now, ideally, this was something that you were supposed to read up on, but if you didn't, no big deal. Ideally, though, you did. A proportion is an equation where two ratios are set equal to each other. So a proportion is an equation where two ratios, so two fractions, are set equal to each other. So in a simple example, and by simple I don't mean easy, but I mean like the most base case would be with just pure fractions. So as an example, 2/3 is equal to 6/9. That's a proportional relationship. You can see that those two things are equivalent. Because if you look at we can look at the same box, the same 3x3 box. I mean, and you don't need to draw this if you don't want to. I'm just gonna do it. On one hand, I'm going to divide it up into thirds. And we see that this area right here, and this is 2/3. And then on the flip side, I could split it up into 9 sections. The 9 equal pieces, and I could highlight 6 of them. That's 6/9. But they're the exact same fraction, just written differently. So that would be a very simple look of a proportion, but more important, like the more common thing that we do with them is we try to find out what the equivalent ratio would be. So we solve proportional relationships. So example. And I realize that's a lot to draw those boxes, so I'm going to hold off for a second. As a total aside, oh yes, go ahead.
Sorry, I don't know. you're going right up on my head of myself, but
Mhm.
also because like, no fractions, you know how you have to like multiply them like x's, so it would be like 6 times 3 and 2 times 9.
That is, so yes, that is
Yeah, I
how,
was making sure, I was like, I don't know if I'm wrong. but-
we're gonna talk, so that's gonna be called, that's called cross multiplication, yes, and that is something we can do. And that's actually how we're gonna solve proportional relationships.
Oh.
So, and that is another way to verify that these two things are equal to each other. So we're gonna solve the following. And you'll see why we're doing this in just a moment. You'll see why, because we're going to talk about similar triangles in just a little bit. So solve the following. Part A will be 4/12 equals x/9. And part B will be x/20 equals 6/15. Just because it can't, like, I'm being reminded of it. We're gonna talk in chapter 3, we're gonna talk about consumer math, but one of the things you start off with in that section is talking about percentages. And please remind me of if you can, I mean, this is like 10 weeks down the line. Just because it happened today, I got an email from the college talking about COLAs, cost of living adjustments. And so the email sent out and said, we're getting a what was it, a total, a 15% raise or whatever over 3 years. And it's because there's like a 7%, did I say 15?
Yeah,
There's a 7 and then there's an 8% raise. That's not 15%. If they happen at the exact same time, it would be 15%. But because it's 7%, then 8% afterwards, it's actually a little bit more than 15%. And so whoever sent out that email was not doing their math right. And I kind of want to send them an email correction saying, actually, it's a little more than that. But then I'd be that guy. I'd be that person. Yes.
Sir, is that a 5, the top one, or is it a 6?
That that is a 6,
Okay,
but I'm going to make that a lot better. Thank you.
no, the 5 was fine, it's just a 6,
That's
okay,
there we go.
thank you,
There we go.
that's the best.
Thank you guys.
Thank you.
Thank you for keeping me honest. I appreciate it. This is actually making me have better handwriting, so I appreciate it. So part A, you can rewrite it if you want to. I'd recommend so. So 4/12 equals x/9. There are several different ways you can solve this. The main way, the simplest way, the fastest way is through cross multiplication. So what you do is you multiply like this. So you take whatever number that you're going towards and you multiply them together. So this becomes 12 times x equals 4 times 9. And then, so you like simplifying it just a little bit, we've got 12x equals 36. And how, like, so x is a variable. We're trying to figure out what x is. And if you have some background with solving equations, excellent. That's awesome. Great, great news. But if you're still a little bit rusty on them, the way I like to think about it is you're trying to get x by itself. Imagine you're having a house party and you find out that your parents are coming home and you weren't supposed to have that party. You want to get rid of the people furthest away from you first, the people that you don't know, because they're not going to be your bros. They're not going to help you clean up, but you can trust your people that are friends, that they're probably going to help you clean up, right? So you want to get rid of the people outside first and then move your way inwards. So here we don't have anybody outside of us. We just have our close friends, that 12. And in order to get rid of the 12, you have to undo the operation. So it's that 12 is being multiplied into the x. So to undo it, we're going to divide by 12. Multiplication and division are opposite operations, just like addition and subtraction are opposite operations. So we will divide both sides by 12. And that cancels it on the left. And then that gives us x is equal to 36 divided by 12, which is 3. And so this is just as another small aside. This is why I like to add color to my notes. Because you see, if you were looking back at your notes, like, why did this happen? Or like, why did these things happen? Whereas if you have it in color, like, oh, that's what I did. I did that. I caused it to get multiplied. Like I caused them to get multiplied together, but I cross multiplication, and then I divided by 12. Is it required once again? No, but I highly recommend it. Even one color, it helps a lot. But anyways, one thing I just want to make sure is crystal clear though about cross multiplication. Cross multiplication can only work. You can only do this trick if you have fraction equals a fraction. That is the only time that cross multiplication works. If this had been 4, you don't need to write this down, but if this had been 4 divided by 12 equals x over 9 plus 7, that is no longer a fraction equals a fraction, and you cannot use cross multiplication. Cross multiplication only works if you have fraction equals fraction. So don't get caught up in that situation. I don't think we'll really encounter that situation too often, if at all, but just in case you encounter it in the wild, it stumbles upon you in a bush, or if I come popping up and see you at Albertsons or at Smith's or something. It has happened before, and I do ask questions. I do. Not really. No, let's be real, guys. I don't exist outside of this classroom. I don't have a life. That's not because I don't exist. It's because I'm a math person. I don't have a life. Anyways, burn on me. B, x over 20 equals 6 over 15. Same thing. We got a fraction equals a fraction. And so we're going to cross multiply. And you get 15 times x, or 15x equals 20 times 6, or 6 times 20. It doesn't matter whichever way you want to do it. If you feel comfortable skipping some arithmetic, some algebra, please feel free to ask. And so that should be 120, right? So we get 15x equals 120. To get the x by itself, we got to get rid of that 15. Since that 15 is being multiplied into the x, we're going to divide to undo it. And that gives us it canceling on the left, and x will equal, is it, what was it? 7? 8. All right. Any questions on that? Coming along? Is it warm in here? Is it just say what? It's comfortable. I might be at the kind of like that late stage of the sickness where I'm no longer sick, but I got the what do they say? It's like that post sickness cough and things like that. So I'm still recovering a little bit, but I'm no longer actually sick. Maybe that's what's going on. But okay. Sorry for the sidetrack. Similar triangles. The reason why we're talking about proportional relationships is to talk about similar triangles. So, similar triangles, the definition. Similar triangles are triangles that have the same angle measurements but different side lengths. With the same angle measurements but different side lengths. If you've ever messed with a picture in a Word document and increase the size and stuff, you're making similar shapes. So one way to do it, sometimes they're right next to each other and they're similar, but other times they're inscribed in each other. So one such example is this. I'm going to draw this one. And I'm going to copy this so I can. Let's just do it like that. So you see, you have two different triangles here. You have this one right here. And then you also have, and so I'm going to copy that. That one. I'm going to take this one. I'm going to do a partial. So, so you have this triangle breaking off into two different triangles that have the exact same angle measurements. They're virtually the same. It's just one of them is a bigger version of the other. And you could just take this right here and I could just expand it and it'll line up perfectly, right? Those are what similar triangles are. So similar triangles are ones that have the exact same angle measurements, but different side length measurements. Now, the reason that's very, very awesome about them, and once again, awesome, I'm being abusive of my language. This is not an awesome fact, but I think it's awesome, is that similar triangles have corresponding angles that are equal in measure and corresponding sides that are equal in proportion. I wrote that very quickly. I know I write things very quick. So I'm going to take a second so we can digest what that means. So angles, corresponding angles. I'll let you write that down so we can look at it first. These I'm gonna kind of color code them. This is a corresponding angle. Those are the corresponding angles, and those are equal to each other. They are just they're the same thing. If this angle's 45 degrees, so is this angle. And then what they're saying is that the side lengths, this side length and this side length, those are corresponding side lengths, and they are proportional. So if we knew that this is like, let's just say for the sake of an argument that this side length was double this. So I'm going to put these here for a second. Don't write them down. Let's just say this was 4 and this was 8. So the bigger triangle side length was double. Then if I knew that this was 7, I'd automatically know that this was 14 because they're proportional. So if one of them is double the other, then all the side lengths of the bigger one are double. And so you can set those up with proportions. So how to make sure you're consistent. Consistent with your proportions. Oh, thank you. Good catch, good catch. Usually don't make that. Darn. So the reason why I say this is sometimes they're right next to each other and they're in the exact same orientation, which is awesome. If that happens, great. Super quick to do. But every once in a while they get skewed. One is in one direction and one is in a completely different orientation. So the key is going to be, I'm going to say color code. So I'm going to draw two similar triangles, but I'm going to draw them in completely different orientations. So first one I'm going to draw like this. And then because I have a tablet, I can do this. Sadly, you guys cannot. But you see how they're in completely different orientations. And while it might, if your mind works fine with this, awesome. Kudos to you. That's great. Me personally, it takes me a second to make sure I set these things up right. So what I like to do is I like to color code them. So if I'm drawing these things, I either use a highlighter or I use pens, and you don't even need to use color. You can also just, so I'll show you how you can do it without color. But what I do is I highlight them based on, I look for the largest side length, then I look for the smallest side length, smallest side lengths, and then I do the last one. So smallest side length, or largest side length is this one. So I'm going to highlight that in green. And then I'm going to find the corresponding longest side length on the smaller similar triangle, which ends up being this one. Then I'm going to do the shortest one, which I'll do it like, it doesn't matter what color you use. So that would be the top one for this one right here. And that must be this one here. And so now I'm left with only one left over. So that must be the other side length, the middle side length. That, like that. This will allow me to set up proportional relationships a lot faster, at least in my opinion. And so you don't have to have color to do this. You could just as easily, I'll show you what I can do. If I don't want to use, if I'm willfully defiant and don't want to use color, that's okay. What you can do is you can just squiggle code it. So like maybe this one I do in like this. That was this one, oops, biggest side length, like this, and then I could do like swirlies on this one. And then the other one I could just leave blank. You don't have to have color to do this, but I really, really recommend that you do it because it makes it so much easier to set up your proportional relationships. Not required, but it will save you a lot of heartache and a lot of mistakes. So let's do an example. Given the similar triangles, find DE and DF. Luckily for us on this one, they are in the same orientation, so it's not too terrible to find out which side lengths correspond, but still should do it as practice. So it looks like this, this, this. And then I'm going to copy and paste and make it smaller. Aha. That, and the first one is triangle A, bottom left is B, bottom right is C, and this is D, E, F. Write those triangles before I put in the numbers, just so it's easier to follow. Whatever reason, someone keeps writing my name or Professor K, Math 120E. I'm very concerned, like I'm confused why they keep writing it, so I'm asking. We're gonna play what is it, The Lighthouse? Is that the one with Keanu Reeves and Sandra Bullock? Yeah, I'm doing the lighthouse situation here. So for A, side length AB is 17 feet. Side length AC is 15 feet. And side length BC is 11 feet. So we have all the measurements of triangle ABC. And then triangle DEF, we only know E to F. We know that is 8 feet. So we don't know what DE and we don't know what DF are. So let's just call them two variables. It doesn't matter what you choose. I'm going to choose X and Y, but you can use whatever letters you want, whatever symbols you want. So I'll call this X. Now let's use a different color. X and Y. So for my solution, the first thing I'm going to do is I'm going to color code. So I'm going to find the biggest side length. Highlight that in green. Doesn't matter what thing you do. So I'm going to do that one. And that corresponds to DE. The shortest side length was BC. I'll do that one in blue. And that corresponds to EF. And the last one, that. And so you can set, this is one of the great things and also one of the terrible things about similar triangles, is there are so many proportional relationships you can set up. You can, like, the most common one is to do things like this. You can do big green over small green is equal to big blue over small blue, which is equal to big red divided by small red. That's one set of proportional relationships that you can set up. Any one of those, you can set big green over small green equal to big red over small red. You could set big blue over small blue equal to big red over small red. Or you could do the first two, big green over small green is equal to big blue over small blue. As long as you're consistent, if your big triangle is up top in the numerator, then then on the other side, your other big should be in the numerator as well. You don't want to flip it. So it has to be big over small equals big over small, or you can do it by color. You can do, you can do, or you could do something like big green over big blue equals small green over small blue. And so on and so forth. You can do big green over big red is equal to small green over small red. As long as you're consistent, everything should work out. I recommend just keeping this one. This is the nicest form. but it's not wrong, like. This is usually best. These are usually the best ones to do, but it's not required. If you want to go rogue, you can do that. But just, and it doesn't even need to be big over small. It could be small over big. As long as you're consistent, that's all I care about. So we want to know DE and DF. So let's just solve for X first. So if we want to find DE, we'll do big green over, like, I mean, do you want to do small green on top or small green on bottom? Doesn't matter to me. Small green on bottom. I get, and if you want to, it's a great bonding experience with your significant other. Try and do it in different ways and see if you get the same answer. Highly recommend. It's a great bonding experience. You and your partner will really get to know each other that way. That's how my wife and I bond. So I'm assuming that's how everyone does it. So, right now, I'm kidding. So big green over, we'll write it down. So big green over small green equals. Should I do big red over small red, or should I do big blue over small blue? Or does it matter? It does matter right now, yes. Because if I were to do big red over small red, let's like don't write this down, but if I were to do that, I'd get, so big green is 17 divided by small green, which is X. If I were to do big red over small red, I would get 15 over Y. Now I have an equation that has two variables and I can't solve for one over the other. So that's the reason why I can't use red yet. Now, if I find out, and you'll see that in a second. So it's better in this case to do big blue over, big green over small green is equal to big blue over small blue. Since I put the big triangle up top in the numerator, I have to put the big blue on top as well. So small blue. So big blue is 11 over small blue, which is 8. And then that's a proportional relationship. That's a fraction equals a fraction. So I can use cross multiplication and get 11x is equal to 80 plus 56. 80 plus 56 is 136. Yes. To solve for x, we need to divide both sides by 11 to get that x by itself. And x is equal to 12.3636 dot, 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 dot. And let's just round to the nearest tenth to the first decimal place. So if we're rounding to one decimal place, we look to the number to the right of the first decimal. That number is larger than 5. So we will round up to say that x is approximately 12.4 feet. But once again, for the homework and stuff, pay attention to how many decimal places it wants you to round to. Now, oh yes, go ahead.
So that's for the next one. So could you only do big blue, small blue to get the variable of y?
Mm-hmm.
Or because you already have the variable for x, would you do it that way, or would it cause more problems?
Excellent question. So now that we know what x is, now that we know what the green side length is, we can now use it. However, the problem that arises here is that we rounded it. So like if it gave us a perfectly nice number, then we could use it and definitely get the same answer. However, because we rounded it, then we'll be basically double rounding. Like if we were to use it to solve for y, we'd be using an approximated measurement with an exact measurement, and it won't work out perfectly. Now, that being said, if you do that on a quiz or on the exam, not a problem, because I'm looking at it, I see your work, I can give you full credit. I might make a comment saying, like, technically speaking, you should use the more exact measurement, but on Canvas, it won't see it that way, so it'll mark you wrong, but if that happens, let me know, I'll give you full credit back. Because you're doing it correctly, it's just, you're using approximation, which will no longer give you the exact answer. Great question. So to do the next one, we'll do big red over small red. Big red over small red equals big blue over small blue. Excellent questions, guys, by the way. Thank you. So big red is 15 over small red is Y equals big blue, which is 11 over small blue, which is 8. I hope you can see why I like to color code, because you're dealing with 4 different measurements. It can be a little bit daunting to like keep tracing everything back. Cross multiply again. You get 11y is equal to 80 plus 40 is 120. And then once again, to solve for y, we're going to divide both sides by 11 to get rid of that 11 on the left-hand side. And get y is equal to 120 divided by 120 divided by 11 is 10.909. And so rounding that to the nearest tenth, looking at the digit to the right, so looking at the second decimal place, that is less than 5, so we will round down to 10.9. So y is approximately, not g, y is approximately 10.9 feet. Now, like, yes, go ahead.
So are we gonna write in our answer y equals or the x?
Excellent question. So that is a great question. Because I labeled X and Y on my picture, I can just use X equals and Y equals. But if you did not label them, then like if you didn't if you had just done this, imagine like when I'm grading this thing, imagine I'm an alien and I only have what you have presented in front of me. If you don't say what X and Y are, I have no idea what they are. So what is X? What is Y? Is X DE or is it DF? I don't know. So if you don't label it on your picture, then you have to write DE equals and DF equals. But if you do label it like I did, then you can just say X equals and Y equals. But excellent question. So it depends, I guess, is the answer. And to show you, so this is what happens. If you decided to do big red over small red, big R over small r equals big G over small g, you get 15 over y equals big green is 17 over 12.4. And if you do this, you'll get so 15 times 12.4, divide that by 17, you end up with 10.941. So like by doing all the work here, you get y equals 10.941 . And so you would actually end up with the same answer, but that wouldn't necessarily be guaranteed. It could end up being that you get 10.95, which you'd round up, and then you get the wrong answer, but it's close enough for me. I would rate it as full credit on an exam. Canvas would mark it wrong, but you could let me know and I'd give you full credit back.
So it's not.
So it is 10.9 because we're rounding to the nearest tenth.
Okay.
Yes. If we were rounding to the nearest whole number, it would be 11.
Okay.
All right. I only have one more of these things. We're not going to do it today. We're gonna take care of that on Monday or no, Tuesday of next week. So if you have any questions, feel yes.
Hey, so I think I did homework for this week my last week.
Okay.
So, and I had the right answers, but I really got one.
Okay.
So Cameron didn't count those. And I had to retake all the things.
Oh no, I'm sorry.
Yeah, so, but no, most of the answers were good.
Okay.
Okay.
Gotcha. If you can email me about that, like if you need more, like another attempt, since we didn't get to finish it, let me know. And if you're talking about the quiz, since the quiz has 3 attempts,
Okay.
Okay, let me know, and since we didn't get to finish it yet, I can give you additional temps, because we didn't get to finish it yet.
Mhm.
All right, so yes, right now it does say on Canvas that the homework for 1.3 is due on Sunday. I'm gonna change that as soon as class is over, okay? So that homework will now be due next Sunday. So anyways, guys, if you have any questions, feel free to email me. Otherwise, you guys have a great rest of your day and a great weekend, and I will see you guys on Tuesday.